In this example, we're shown a slope field below, and we want to match this to one of the differential equations on the right-hand side. One of the keys to do this is to take a look at where the slopes of the tangent lines are zero. So that occurs right here. So we've got, let's see, we've got this area right here, and this is where y is equal to zero. So wherever y is equal to zero, we need the slopes of those tangent lines to be zero. And then over here, we also have a situation where we've got all of the slopes of the tangent lines being zero, and that happens to be when x is equal to -1. If we take a look at the setup on the right-hand side for the first one, right here, we're taking a look at part A, we can see that x times y is going to give us the slopes of those tangent lines, and x times y has to be 0 when x is either -1 or y is equal to 0. Now, this particular expression does work when y is equal to 0. However, this doesn't work for every single ordered pair that has an x value of -1. Let's test, for instance, the point -1, 2. And we can see the point -1, 2 over here on the graph. So -1, 2 is this location right here. And -1, 2, try to erase some of this other stuff for you. That's not erasing. Oh, well, there we go. So -1, 2 is the point that we highlighted or pointed out right here in the magenta. And if we actually go ahead and use this point, we're going to have -1 times 2, which is -2. And that slope right here is definitely not -2, it's 0. So A can't be the correct answer. If we take a look at part B, so now we're moving on to part B here, we've got x, y minus y, and sometimes it's useful to factor out or to get the product of two factors. So I know that the greatest common factor between x, y, and y is y. And I also know that this one does work when y is equal to 0. X doesn't matter, and 0 times anything is 0. Let's see if it works for our ordered pair -1, 2. So in this case, we have 2 times -1 minus 1. And the question here really is that 0? Because we know right here at -1, 2, that slope has to be 0. Well, this is not 0. 2 times -2 is -4, so this can't be the correct one. And if we take a look at the next piece right here, we can still factor a y out, and we've got x plus 1. So what's going to happen here with our test point? Well, if we use our test point, we're going to have 2 times -1 plus 1, which is 0. So I'm going to put a little star here. This might actually be the one. Let's work through the next few together. So I can factor an x out of this one, and I'm left with y plus 1. And if I substitute my -1 in and my 2 for y, I find that this slope does not equal 0. Once again, we're just testing that point, -1, 2. And then also we've got another one down here to work with. So we've got x plus 1 to the third power should be 0. So we've got -1 plus 1 to the third power is equal to 0, and that's true. However, if the x value is something different, like let's imagine that the x value was, we'll make it 2 right over here. So we're looking at this point, and we're wondering, is that slope 0? So we're going to test another point. This is fine to test that, but we're just going to test another one. We're going to test when x is 2 here. So we've got 2 plus 1 to the third power, which is definitely not 0. So this one can't be the answer. The only one we're left with is part C. And let me explain something a little bit more to you. Let's just take a look at, let's try to choose a color here. How about blue? Hopefully that's blue. And let's just take a look at this piece right here. So we have two factors. we have x, and then we have, oops, sorry, that's the wrong equation. Erase that. Move up to the top one. Here's part C. Let's focus on this one. So we have two factors. We have y as a factor, and then we have x plus 1 as a factor. Now, when y is 0, this whole expression works out to be 0. And when x is -1 plus 1 is 0, so the y doesn't matter. So this expression, y times x plus 1, or xy plus y, actually does produce the situation that we see in the example.